Hello, everyone. This is David Pompiani. We're back for another episode on my channel to talk about the intersection between geology and human history and anthropology. And today I have a guest that I'm excited to introduce. His name is Dr. Christopher Jass. He is a paleontologist at the Royal Alberta Museum. Hello, Chris.
Hey, how are you?
Welcome to the channel. Chris specializes in quaternary vertebrate paleontology, and his research focuses particularly on Ice Age mammals, their ecology, and how past climate shifts have influenced faunal distributions across North America. And I'm excited to have Chris on here because the previous episodes on my channel, we've talked about things like the Younger Dryas. Chris, you probably have heard of the Younger Dryas. And it's definitely a climate event that happened near the end of the Pleistocene and the transition into the Holocene. There's been a lot of questions surrounding that, a lot of interest surrounding the Younger Dryas, and I think more broadly, the human history of the Americas, the original migrations of people across the Bering Land Bridge and making their home in North America. But I feel like no one has actually looked at or talked to the actual experts in the paleontology of these crazy megafauna that's almost like science fiction when you think about it. When you picture, I was reading through the types of megafauna found at the Mammoth site, which you work at, and I'll let you talk about. But nobody's talked to those paleontologists. Everyone's looking at the archaeologists and the podcasts and the meteorite impacts and this and that. But I wanted to get an on-the-ground, experienced paleontologist to come and talk about the extinction of these crazy megafauna, talk about the types there were, the type of environments that we would have experienced near the end of the Ice Age, and broadly their extinction. So, Chris, start me off. How did you get into paleontology? Where did you do your PhD? And how did you get into Ice Age or megafaunal paleontology from the Pleistocene and Holocene?
Sure. So as a kid, I grew up in the Black Hills in South Dakota, and I got interested in paleontology probably when I was 8 years old. My uncle was a geological engineer who had a real passion for ammonite hunting. So my introduction to paleontology was really going out with my uncle collecting 65, 66 million-year-old ammonites out of the Pure Shale in South Dakota. And I ended up with a little detour in university. I had a professor who was teaching a class on social problems, actually, and got me really interested in sociology. So my undergraduate degree is in sociology and social science. But when I was 21, I was looking for a summer job, and my grandparents lived on a farm just outside of a little town in southwestern South Dakota called Hot Springs. And the town they actually lived in was named Oral. We were about 20 miles outside of Hot Springs. And I needed a summer job. And the Mammoth site was hiring tour guides. And so I got hired as a tour guide at the Mammoth site. That kind of rekindled my interest in paleontology. And the principal investigators at the time were Larry Agenbrod and Jim Mead. And I was always asking them questions and pestering them when they were around. And at some point, they said, hey, you should come down and do our master's program in Arizona. So I ended up doing that. I went down and did a master's degree in quaternary studies at Northern Arizona University. Jim was my advisor. Larry was on my committee, but it was a great program, interdisciplinary program. So we got exposed to, a little bit of geology, paleontology, archaeology. It was the quaternary writ large. It was a phenomenal program. And then I ended up going from there to University of Texas at Austin, and I did my PhD there. And my real interest for both my master's and my PhD focused on working on cave sites in Western North America. So I was actually mostly working on smaller critters. But one of the things I've always been interested in is the role that elevation plays in the face of climate change and potentially allowing certain animal populations to persist through time. A lot of my master's work and PhD work focused on that. And I was incredibly lucky. I was one of the few people who, like, literally the day that I turned in the final hard paper copy of my dissertation, I got home and there was a phone call inviting me for an interview at the Royal Alberta Museum in Edmonton. And so I came up to Edmonton in January of 2008, interviewed for the position, and we moved here shortly thereafter. And since that time, I spent a year as a director of research at the Mammoth site in South Dakota, and I still maintain a role there as a principal investigator of the site. I've taken on the role of principal investigator at the Mammoth site. So curator of Quaternary Paleontology at the Royal Alberta Museum and principal investigator of the Mammoth site. So it's kind of a circuitous path.
Sometimes that's the story when you talk to the geologists. I feel like a lot of them start off in different careers or different paths, but then they fall in love with it, usually with a class or something that interests them from childhood.
Yeah.
And it's interesting hearing everyone's story. So thanks for sharing that.
Yeah.
So you ended up at the Mammoth site, and the Mammoth site is unique because it's like one of the best preserved, let's say, like boneyards, graveyards. It's a sinkhole that formed like 140 to 160,000 years ago, based on what I've been reading. And it kind of had muddy sides, steep sides that big things would fall in and preserve these big, huge megafauna, in particular, big mammoths. I think, would it say most of them are the Columbian mammoths, like of the 60 skeletons, correct?
Yeah.
Big of the the mammoth. I have a hard time saying the actual Latin name for their family.
The proboscideans.
Yeah, proboscideans.
Yeah.
But yeah, most of them are these big things. So you started kind of working there. It was like you're kind of where you first were exposed to paleontology. This mammoth site is probably one of the best sites, in addition to like the La Brea tar pit, right? And California, for other preserved like megafauna fossils.
Yeah.
Mm-hmm.
They're, similar in that they're both natural traps, but there are some significant differences. One being the time frame. At one point, we thought the Mammoth site was roughly 26,000 years old, and that was based on radiocarbon dating of bone apatite. So because the bones at the Mammoth site were preserved because there was a warm spring that was feeding up into the sinkhole, that warm water probably leached a lot of the collagen out of the bones. So we've historically had a challenge in terms of accurately dating that site. Bone apatite is not the best thing to date in terms of radiocarbon dating. It doesn't always produce really accurate dates. And so my predecessor there, Jim Mead, initiated some work, some OSL work. It's optically stimulated luminescence. Mm-hmm. And I'm not even going to pretend to be an expert in the techniques in terms of how that works, but that's work that's been led by Shannon Mahan. And essentially the OSL dates give us a very different age for the site than the radiocarbon dates do. But there is increasingly compelling evidence from other areas that suggests that the OSL dates are probably more correct than the radiocarbon date.
Those are the 140 to 190,000 year old dates.
Yeah,
estimate I'm getting.
We're currently revising a paper for resubmission on that, and the age range is going to be roughly between 125,000 at the top and 255,000 at the lowest, near the lowest point where we've excavated. So
okay.
So there's a pretty big age range there. So in terms of comparisons with La Brea, that age range is significantly older than a lot of the material that comes out of the tar pits. But
really, what's the age of the La Brea tar pits?
The tar pits tend to be closer to the latest Pleistocene, to the terminal Pleistocene. So between 30 and 10,000 years old, a lot of the material that comes out of the tar pits. The other big difference between the two is the Mammoth site is really, really biased towards animals of a particular body size. Whereas La Brea, with the tar pits, anything that touches the tar is getting trapped. So you're getting small animals, you're getting big animals, you're getting carnivore. The Mammoth site is really biased towards mammoths. We do get some other animals, some other fauna there, but by far, mammoths are the most prevalent animal that's trapped at the site. So it's really, really biased towards animals of a particular body size. And that, I think, reflects the nature of the trap. So in the southern Black Hills, you have lots of caves. And over time, as those caves continue to erode and grow and expand, eventually the size of the cave becomes so big that it can't support the weight of the rock above it, and you get a collapse feature that we call a sinkhole. In the southern Black Hills, there's lots of spring water, lots of artesian springs, and an artesian spring fed up into the sinkhole. And we think that it's probably the water or vegetation around the sinkhole that was probably attracting mammoths to the water. But the geologic formation that sat on top of that collapse, which is called the Spearfish Formation, it's a shale that's really, really slippery when it's wet. So you combine water with sinkhole walls that are made of this shale, and you have a really bad combination for a 20,000-pound animal that's not built for climbing, right? Some other animals may have been able to get in and get out. It's actually surprising we did find short-faced bear there, which is kind of surprising because bears are generally pretty good climbers. They can scramble around fairly well. So it was surprising to find the bear there. But the site is definitely biased towards those really big animals. And I think it's just it's a feature of that particular trap. So in the sense that both La Brea and the Mammoth site are natural traps, yes, that's true. But they were trapping animals in very, very different ways.
And the Mammoth site and La Brea, they're kind of like the two most famous sites for these well-preserved megafaunal fossils in North America.
Yeah,
Okay.
absolutely.
I know there's some cave deposits, but like in terms of lots of preserved stuff, I thought those two kind of were like the most famous. But that's very interesting that you brought up the nature of the trap. And like doing a little digging before talking with you, I pulled up a list of, things that you found at the Mammoth site. And then I had a list of common megafauna that should have been present in the Dakotas at the same time. And they're not present in the trap, let's call it the sinkhole. Like, for example, Smilodon. Saber-toothed cat should have been there, the American lion, and these are very small-bodied, able to climb out of holes, whereas the Mammoth site, you found, at least according to the website, 58 Columbian mammoths, 3 woolly mammoths, a short-faced bear, like you mentioned, which is strange. Maybe they were injured, maybe they fell, camel, llamas, ground sloths, which all makes sense. They don't seem to be very good climbers. And then obviously like rodents and birds, etc., the things that have fallen in.
No ground sloths yet.
No ground sloths.
No,
okay.
We have a display on ground sloths, and there's a display in one of the exhibit halls, but we actually haven't found ground sloths in the sinkhole yet. So
that's very interesting. And but you haven't found any horses though?
There's
what is it called? The North American horse? Yeah, the one that's before the Europeans.
There's several different flavors of horse that were around during the Ice Age, but we have not found clear-cut evidence of horse. And even some of those other animals you mentioned, like the camel, for a lot of those taxa, we just have bits and pieces. So we don't actually know for some of those taxa whether those small specimens represent bones that somehow were washed into the sinkhole, or do they represent animals that were trapped? And we just haven't found more. The two that definitively were either stuck in the sinkhole or their entire body was in the sinkhole at one point mammoth and short-faced bear. But even for animals like the camels, we just have some fairly small pieces. So theoretically, if those animals were trapped, as we continue to dig, we should find more of those skeletal elements.
So there's a lot more to excavate still at the Mammoth site?
Oh yeah,
Oh, yeah.
there's enough there that like it's not going to be finished by the end of my career. I mean, there's one of the things that is cool about the site. So we've been at that particular site, we've been working at it for 50 years. Last year was the 50th anniversary of the discovery of the site. And there is still a lot to learn and a lot to excavate. So a lot of the excavation has taken place around the margins of the sinkhole. And that's because that's based on the idea that, well, these animals were trying to get out when they died. So we're going to find a lot of things around the edges. And that's been true. The whole center of the sinkhole has really it's not been touched in terms of excavation. And part of that is because of the steepness. The sinkhole has a fairly steep dip. So the angle of the sediments is quite steep. And that means as we move to the center of the sinkhole, we have to dig deeper to get down to layers that would theoretically have bones on them. So a lot of those areas are unexcavated. The biggest challenge moving forward is trying to decide, do we take out what we've exposed so we can see if there's more there? And what is the purpose in doing that? So one of the goals of the Mammoth site has always been to be an in situ site. So people can come and see the bones right where those animals died. And I've been associated with that site since I was 20 years old. And I never fail to be inspired. I never fail to feel something when I walk into that building and see those bones right where those animals were living, right where they were dying. So there's something powerful in that. So one of the things that we have to consider moving forward is, well, do we take stuff out to see what's below it? We know at the deepest point that we've dug that we could still go 45 feet below that and be in the sinkhole. So there's potentially a lot more there. But we're at a point where for some areas, we have to kind of balance the interpretive side of the site and the educational side of the site with the scientific side. And for me, we're probably not going to move a lot of stuff out to see what's below until we have a really, really good research question that would drive that. And just looking for one more mammoth isn't enough for me. We need a better scientific question than that. So right now, the focus of the excavation that we're doing tends to be in areas that really haven't been explored before. So I would say, yeah, doing a rough estimate, there's probably somewhere between 50 and 60% of the site that could still be theoretically excavated at some point.
So there's a chance you will find a saber-tooth.
There is. And it's funny you bring up the saber-tooth because everybody
That's what I want to know.
Yeah, everybody that I've ever worked with on the dig side, like I have made some big promises if they find me a saber-tooth cat in there. You get lunch for a year, free drinks for life, whatever. That I can't count the number of people who have been working on the site as excavators who have said, hey, you find me a saber-toothed cat and there will be reward for it.
Yeah. And it probably had a broken foot if it's in there. It fell, broke, and it can't climb. Maybe. I mean, otherwise, I feel like if anything's going to escape a little mud hole trap like that, it's going to be a cat, a big cat.
Exactly. And that's part of the reason why I don't think we have why we don't have those animals there is because they were probably agile enough to get out.
So if we're a person watching this and we have just a slight interest in geology and we don't know very much about paleontology of the late Pleistocene in North America. Tell us about what would the Mammoth site look like? What would the Dakotas, let's just say the Midwest, the Dakotas look like, around 18 to 20,000 years ago before humans arrived? Imagine we're in like a grassland environment and we're looking across the landscape near this site. What kind of animals would we have encountered as we walked across the site 20,000 years ago?
Sure. So I'm actually going to take you all the way from Alberta down to South Dakota.
Perfect.
So 18 to 20,000 years ago, here where I'm sitting today in Edmonton, Alberta, there would be nothing here but ice. 18 to 20,000 years ago is the last glacial maximum. You have ice coming out of the Rocky Mountains that's coalescing with ice coming from the Canadian Shield. And essentially all of where I'm sitting at today would be covered by ice. Those ice sheets extend down into parts of the U.S. So in South Dakota, the Laurentide ice sheet, the sheet coming from northeastern Canada, is extending down to approximately where the Missouri River is at today. So the Missouri River divides South Dakota into a western half and an eastern half. And the eastern half, the topography of the eastern half of South Dakota is quite different than the western half because glaciers made it to the Missouri River. The Black Hills remained unglaciated during that time frame, but you're not very far from the ice. So one of the things that we see, particularly with some of the small animals from cave sites at that time, you see taxa that today only occur in the Arctic. You see types of voles and lemmings that only occur in parts of northern Canada today that are actually roaming around the Black Hills. You likely have populations of mammoths. There should be bison. You would theoretically have maybe not ground sloths in that area at that particular time, but
Are they like more warm weather?
Yeah.
Okay.
And we think from work that's been done by colleagues up in the Yukon and some things we've observed here in Alberta, we think that the records that we get of sloths in the north tend to be tied to interglacial times. So warmer time periods when that ice is not here, when those ice sheets aren't here. So they're moving northward at that time. So I suspect that at the time, 18 to 20,000 years ago, you don't have ground sloths in the Black Hills region. Now that said, we could potentially find them at the Mammoth site because the Mammoth site we now know occupies a different time frame, an older time frame, where we once thought it was right there around full glacial, last glacial maximum times. We now know that it's older and it encompasses some of those interglacial time frames. But yeah, you're going to have at the time that ice is, covering parts of eastern South Dakota, you likely have a more northern-like environment, a more tundra-like environment.
Arctic.
Yeah.
Very
One of the challenges for interpreting that in the Black Hills has been that we don't have a lot of deep lakes. We don't have a lot of natural lakes. It's we're part of the arid West, so getting good deep time paleo environmental records has been challenging, except for some of the cave sites that we're working on in the Black Hills. And one of those sites is one that we're still currently working on. It's one of the best sequences that I've ever seen in a cave. The stratigraphy seems to be relatively intact. And we go from about 3,000 years ago at the top of the excavation to roughly 14,000 years ago where we're at. We know there's more sediments there, and I'm hoping that those sediments are going to take us all the way through the full glacial, and we'll have a continuous sequence of time where we can really look at how animal populations and potentially environments were turning over. A lot of that's work in progress, and I can't comment too much on that, but we are seeing some pretty significant changes happening during those time frames that reflect that transition out of the full glacial environment into environments that essentially are the modern environments that we see today.
And there's a lot of, in the Midwest, the common way to get a paleoclimate record would be to sediment core a lake. These are similar to taking like tree ring cores, ice cores. But as you mentioned, Chris, and just for the viewer, that there, in that part of the Dakotas, Western Dakotas, there's very limited natural lakes that extend back in time far enough to actually measure paleoclimate, more directly during the last glacial maximum is kind of what you're saying.
Yeah.
And then a lot of the places are just under ice during the last glacial maximum. So there's nothing geologically being recorded essentially at those sites.
Yeah. So here in Alberta, um, we actually have a huge gap in the faunal record here, from roughly 22,000 years ago radiocarbon to roughly 12,000 years ago radiocarbon. We have almost nothing that dates in that 10,000 year interval. And that represents well, we think what it represents is either the presence of ice or the proximity of ice rendering the landscape uninhabitable by plants and animals. So the ice had a huge effect. And in some ways it creates some challenges for interpreting, what's going on during those timeframes. But up here in Alberta, it's created an interesting natural laboratory because we have that gap. So we know what came before. We've got faunal records from before the last glacial maximum, and then we get faunal records after that. So it's kind of interesting to be in a place where you wipe the slate clean, so to speak. Essentially you have this time period where nothing's living here. And then all of a sudden we have landscapes that are opening up and allowing animals to come back in and repopulate, allowing new creatures, allowing humans move into new areas. So it's a really, really cool laboratory in that sense, because it sort of shows us how you go from a landscape with nothing on it to, what you see when you walk out your door today.
It's fascinating to me. And that transition and the loss of the large mammals across that boundary, this last Pleistocene is something that fascinates me. And digging into into a little bit more, I didn't realize, even as a geologist, there's even several types of mammoths in North America during the, this 20,000, this period we're talking about right before humans arrive. There's several mammoths. So can you talk about the types of mammoths we would encounter in the environments we would have encountered them in?
Sure. Yeah, absolutely. So there's, depending on, which taxonomy you use, there towards the very end of the last ice age, there are 3, potentially 4 different types of mammoths that occur in North America. There's the woolly mammoth that everyone is familiar with. Everybody's seen the Ice Age movies. Mm-hmm. That's the iconic Ice Age critter. So they stand 8 to 10 feet high, have the long shaggy coats. Body size wise, they're not much bigger than an African elephant. They're comparable in size to African and Asian elephants, but they've got the big shaggy coats and they've got big tusks. And those mammoths have old world origins. So those are mammoths that are evolving in the steppe environments of Eurasia and arriving in North America 500, well, maybe not even, I'd have to go back and look at the numbers. But arriving later in the Pleistocene, in the Ice Age. So we've got woolly mammoths. We have Columbian mammoths that evolved endemically in North America. So they are descendants of some of the first mammoths that arrived in North America roughly 1.7 million years ago. And then those populations ultimately led to what we call Columbian mammoths. So Columbian mammoths are a little bit bigger than woolly mammoths, 12 to 14 feet at the shoulder. They probably had hair, but they tend to have a more southerly distribution. We do find both in Alberta. We find both woolies and Columbians. And so then you have this taxon that was named in the Great Lakes region called Mammoths jeffersoni. And it may be that Jeffersoni is actually a group of mammoths that resulted from interbreeding between Columbian mammoths and woolly mammoths. Ancient DNA tells us that those animals were interbreeding, and Mammoths jeffersoni typically has morphologies that are somewhat intermediate between. So whether that's a valid species or not is probably up for debate.
Is it also referred to as the Mammoth americanum?
Mammut americanum would be
Mammut.
the American mastodon. So
Okay.
mastodons are a different evolutionary lineage.
Hmm.
Whereas, like, if mammoths and elephants are first cousins, mammut and mastodons would be distant cousins. So very different tooth structure. Mastodons tend to be found, although we do have a West Coast version of mastodon, and we have, which is Mammut pacificus, and then we have Mammut americanum, which is those are more commonly found in the Great Lakes region. We find both here in Alberta. And we actually just had a paper come out, probably a month ago, that describes evidence of Mammut pacificus, so that West Coast version. Okay. So one of the interesting things about being in Alberta is it's an area that at various times a funnel between northern North America and southern North America. So we get a lot of different animals moving up through and down through this area of the continent.
The ice-free corridor. Yeah.
Yes. Yeah. The so-called ice-free corridor.
So-called.
So one other type of mammoth, and
Okay,
that would be
keep going.
that would be the Pygmy mammoths that occur in the islands off the coast of California. So,
whoa, wait, hold on. I know about the one that occurred in Siberia, right? You know about those pygmy mammoths.
Yes. Yeah.
Okay, there's separate ones off the coast of California, though.
Yeah. Yep.
Whoa.
That's Mammothus exilis. That is the pygmy mammoth that occurs on the Channel Islands off the coast of California.
I got to look that up.
Yeah.
I've never heard about that.
Yeah.
Maybe that'll be another episode.
So.
Okay, so that's interesting. So there are these little island effects. You would say overall, the extinction of the mammoths and mastodons were more like extirpations regionally that kind of coalesced, I feel like, into an overall extinction.
I would argue that very strongly.
Okay, yeah. Okay.
Yeah, the
more I look at this, it makes sense.
And that, especially here, that for me as a researcher has crystallized a lot more because of some of the work that we've done here in Alberta. One of the things that we find here is that mastodons and mammoths both occur here. We find records of them, but all of our radiocarbon dating on mastodons and some of the genetic work suggests that all of our mastodon records are 45,000 years or older. So we have no mastodons that postdate that time, which suggests to me that, we're losing those animals in some regions of North America far in advance of the arrival of people, right? So mastodons are gone from this region well before people arrive. Mammoths are here both before and after, and in conjunction with when people arrive. So for mammoths, the story is different. And not only do I think we have to look at different regions and say, okay, what's going on in this region? When are animals going locally extinct? The extinction pattern is much more nuanced. And because we're in relatively near time, we can actually tweak that out, which I think is really, really interesting. But so we're losing animals in different spots at different times. And
some precede humans. Just to be clear, that's an interesting observation. Sure predate, like 20.
The loss of some populations of some of these megafauna certainly predates humans. Now, the final extinction of a lot of these taxa occurs right around the time that humans arrive. But without a doubt, there are some areas where we're losing some of these taxa at different times for different reasons.
Okay. And I want to just be clear with also, if you're listening to this and you are not an expert in paleontology, I'm now realizing I've always thought mastodon and mammoth was interchangeable, and it's definitely two different species. So that's something I think to remember. Don't find the American mastodon, or if you want to call it, you don't find mastodon at the mammoth site.
We do not.
So why would that be? Are they from more southerly areas? They should have fallen in, right?
So mastodons and mammoths have a very different tooth structure. So mammoths have a very flat tooth structure. So their teeth are made of a series of enamel plates that are cemented together. And actually, the chewing surface of a mammoth tooth looks a lot like the bottom of a tennis shoe. It's really, really flat, and it's got lots of these little enamel ridges on it. Mastodons tend to have a tooth that is more similar to, it's what we would call a bunodont tooth. It's got some big cusps on it. It's more pig-like in terms of the tooth structure. So mastodons are eating different types of vegetation. Mammoths tend to be grousers, or tend to be grazers, sorry, and grousers. I'm conflating my terms here. Mammoths tend to be grazers. Mastodons tend to be browsers. And mastodons are, a lot of the American mastodons that we find tend to be associated with black spruce forests. And so they're, while they're overlapping in time, and we do find them in some of the same deposits, we don't know if they're actually occupying the same environments. So the lack of mastodon at the site and the prevalence of mammoth is probably telling us something about what those landscapes around the mammoth site looked like. There were probably lots of grasses, lots of vegetation, but you had probably less in the way of trees like black spruce or browse vegetation. If we had a lot of that vegetation, we would probably have mastodons in the sinkhole as well.
That's interesting to know. You also don't find any dire wolf in the pit?
No, we don't. We do have some evidence of coyote, and there's some painted material, but we haven't found anything says yes, we absolutely have dire wolf. Again, those are animals that are fairly agile and may be able to scramble their way up. I have no doubt that carnivores were going into the sinkhole. I mean, if there's a 20,000 pound carcass there, something's going to come and eat it. And but I think some of those carnivores were probably agile enough that they were able to make their way out of the sinkhole.
That makes sense. And dogs aren't the best climbers, but I definitely say they're more agile than a bison or a mastodon or a mammoth, let's say.
Yeah. I mean, mammoths really have a big body size and a foot structure that's not built for climbing, working against them, right?
Yeah.
So.
And if they trip, they're going to fall pretty hard too and like break something, like they fall into the cliff, whereas a cat can fall in and maybe get back up and kind of hop out of there. Now, if we're the first peoples coming into the Dakotas, walking across the grasslands for the very first time near the sinkhole, we would have seen like giant herds of Columbian mammoth kind of mixed with probably other prairie grassland predators like lions and wolves, right? How would you have described, like, do Columbian mammoths, would they have traveled in big herds?
Yeah, we actually think so. The mammoth site actually tells us something about mammoth behavior.
Tell us about that.
One of the things that Larry Agenbrod and others noticed early on is when they were looking at the pelvic bones of the mammoths at the site, they were able to evaluate whether those animals were males or females. The size of the pelvic bones size and shape are a little bit different because females give birth. And thus far, all of the mammoths that have been found at the mammoth site are males. And we can use the teeth to come up with age estimates. So mammoths, their teeth erupt in the same fashion that modern elephant teeth erupt. So we're able to look at eruption patterns in modern elephants and use that as a proxy to estimate the age of individual mammoths at the mammoth site. And the vast majority of animals, all of them are male, and most of them tend to be young males. That's really interesting because that's not a graphic distribution that you typically find. There needed to be some explanation for that. And to come up with that explanation, Larry looked towards modern elephant behavior. Modern elephants travel in matriarchal herds. So there's a female matriarch that heads up an elephant herd. And when young males reach sexual maturity, they get the wave goodbye. The mom picks them out. And so essentially what the mammoth site is trapping is mostly young male mammoths that have probably been pushed out of the herd. And those young male mammoths are doing what teenagers of any species, teenagers, certainly teenage humans tend to
Or
do.
mammals of
Yeah.
the mammoths. Yeah.
Yeah, they tend to do risky things, and we suspect that the females and the matriarch, the matriarchs and the herds that they were guiding probably knew that that spot was not a safe spot, and so they stayed away from it. But it was the young, impulsive males who either wanted the water or for whatever reason went into the sinkhole and didn't come back out. So that actually tells us something about the sociality of mammoths. I mean, you would not be wrong to call a mammoth an elephant. They're part of the elephant family, and it makes sense that they would have some behaviors that are pretty in line with what we observe in elephants today.
And elephants remember. Isn't that the saying?
Yeah,
Yeah.
elephants are
never
incredibly
forget.
smart. Yeah.
And especially if they had a traumatic experience at that sinkhole, they would avoid it, it seems like. But it's, that suggests that this information can be carried on or taught or learned, right?
I think there is some really interesting research being done on elephants and elephant behavior and elephant communication. And I by no means am an expert in any of that. So I can't really speak to any of the specifics of the research, but I will say, I think that research is telling us that elephants are far more intelligent and have far more nuanced communication patterns than we would typically recognize. I mean, they communicate at frequencies that humans can't hear. And there is a very social nature. I mean, you just need to watch a documentary on elephant behavior and you go, wow, these are thinking creatures. These are thinking, feeling creatures that, whether they feel in the same way that humans feel or express emotion, it's pretty clear that they have, their minds are exceptional when it comes to comparison with other mammals.
And danger would have been something, or being scared or traumatic experiences, something it seems like animals remember very quickly, especially dogs or cats. And I would imagine elephants. And if something happened there, and they mourn, I'm pretty sure there's evidence that elephants even mourn the deaths of their children or relatives, right?
Yeah.
Or at least speculation about that.
Yeah, there's compelling video that, and maybe when we watch that, we're anthropomorphizing, but I think they're incredibly intelligent animals, and it makes sense to me that if those, more intelligent matriarchs knew that this was not a place to go and mess with because you're putting your life at risk, they probably would have stayed away from it.
Wow. I did see that on the website, I think, and I was wondering, that is strange. It's only young male mammoths. Wow.
I think anybody who's ever been a mom, anytime I would talk about that or still talk about that with people coming through the site, the moms are the ones that are like, oh yeah, the teenage sons who don't listen to their moms are the ones who get into trouble.
Yeah. It's consistent across mammals for sure.
Yeah.
Now, 20,000 years, 20,000 years ago, we're in the grasslands there. And then by about 10,000 years ago, all these, I'm not going to say all of them, many of the large megafauna that were on these landscapes are gone. And with the exception of maybe bison, and I guess if you want to count elk or grizzly bear, I don't know. They seem to be pretty big to me.
Yeah, well, and even some of those like elk and moose arrive in North America quite late. So,
oh, really?
Yeah, so those moose, especially, they are coming into North America. The moose that we have today are coming into North America at around the same time that people are, roughly.
Whoa, I did not know that.
Yeah, so the oldest record of moose that we actually have dated here in Alberta is only about 7,000 years old. So,
wow.
So moose
that's an old world. And I think caribou and elk track human migration, right?
Yep.
Definitely caribou.
Yep.
Through the ice-free corridor, there's a big expansion in the genetics of caribou, I think, at the same time the ice-free corridor opens up. If I remember, a long time ago, I read some paper about this.
Yeah, and we have one of the sites that we're working in southern Alberta is a site called Wally's Beach. Actually, just caribou had been discovered there previously, but we've got records of 10, 11,000-year-old caribou from the very southern part of Alberta. And today, the nearest populations, you have some isolated populations of caribou out in the Canadian Rocky Mountains. But other than that, it would be, you might occasionally see caribou in parts of far northern Alberta, but definitely no caribou roaming around most of Alberta today.
How about white-tailed deer?
Ooh, that's a good one. You know what? I'm going to punt on that one because I just I don't know the record of whitetails enough to comment, to give you an accurate answer on that one.
Yeah, no problem. Now, but going back, so we are at 20,000 years ago, we have all the beautiful megafauna. Humans arrive. We're not going to get into that debate too much, but something like 18, 16, 15,000 years ago, it seems like fairly solid evidence. I just had somebody that worked on the site in Idaho on here with the really old evidence of human activity. It's Lauren Davis.
Okay.
Yeah, he was just on here talking about the White Sands footprints, which
Nice.
If you didn't see my episode, you should watch, because those footprints, I don't think they're as old as they are claiming. They're claiming 20 to 23,000 years. And it seems like there's a lot of debate that took us an hour to talk about all the debate, but it seems like they might be a little bit younger. But anyway, I'm getting off track. I just want to picture, we have these megafauna. We go from that to they're extinct. But I do want to mention that the bison isn't, what would you say didn't go extinct? What kind of megafauna made it at least solidly to the mid-Holocene?
Bison,
obviously, yeah, bison.
Yeah. And you get some of these other things. I mean, you're not wrong about elk and caribou. Those are animals that they were around. They just weren't necessarily spread out throughout North America.
Spread out there.
Yeah, but they certainly would have been around during the Ice Age. So yeah, bison are the big one that make it through, and that's an interesting one. Mm-hmm. So I look at the record here in Alberta. And I talked about the fact we have those pre-glacial records and those post-glacial records that precede and follow the last glacial maximum. If we look at pre-glacial records here, certainly in the Edmonton area, one of the things that we find is that, yeah, there's definitely bison and a lot of bison here, but there is tons of horse. I actually think the pre-glacial landscapes here in Alberta were teeming with horses more so than they were bison. And, we think of Western landscapes in the continental part of Western North America. I mean, those landscapes are characterized by bison. That's our frame of reference. So when did that come to be? Well, after the ice leaves, we see horses come back for a little bit, but that is when bison explode on the landscape. Then bison take off and carry on through. And for me, when we talk about extinctions, one of the things that's always been really sort of a fun intellectual thing to ponder is, okay, why do bison make it through? And why do we lose things like horse and camel? Mammoths, I do actually think that humans probably had an impact on mammoth populations. I think there's good arguments to support that. I don't think humans were the sole cause, but I do think humans had an impact, in part because mammoths are animals that reproduce relatively slowly. So they would, if they're anything like elephants, once every 2.5 years, they're reproducing. So if you're taking individuals out of those slow reproducing populations, that's going to have an impact on the viability of those populations. But that argument doesn't make as much sense with things like camels and horses that reproduce at roughly the same rates that bison do. So why we lose those animals is one that we don't have I don't think we have a great explanation for. A colleague from California, I think it was Eric Scott, I'm going to give Eric credit for it, even if it wasn't him. But I think he's the one who, in a paper that I read, he put forth what I thought was a really compelling hypothesis that maybe it had to do with the physiology of those animals. So when we look at horses eat a lot of grass, but a lot of good stuff comes out the back end. They're not real efficient feeders. Animals like bison are ruminants. So they will eat food, they'll erp it back up, they'll chew it up some more and get more good stuff out of it before it goes out the back end. So the hypothesis was that essentially the physiology of bison allowed them to make better use of the changes in vegetation that had occurred. And in some form or fashion, they outcompeted animals like horses and camels for resources, or they did better. I think it's a really, really interesting hypothesis, but it's a really, really difficult one to test, right? So sometimes those are the best hypotheses, though, the ones that, here's a great hypothesis, but there's no great way to test it.
Yeah. It's like it's as subtle as the digestive system. It's interesting. And other ruminants do well in North America with humans too, like deer are ruminants, a white-tailed deer and elk and obviously cows. And they just love, I don't know, I'm just observing that they like being around humans. They survive in our fragmented forests and they seem to reproduce fast enough at least to keep going. Not cows, but like white-tailed deer and other things. Yeah. But okay, this I think is a good stopping point to get to a review for the listener, because I'm sure you've thought about this so much. The competing theories, we have the 20,000 years and then we're extinct by 10,000 years minus the bison. That's a mystery, but we know the Columbian mammoth gone, the woolly mammoth gone, the giant ground sloth gone, short-faced bear gone, a saber-toothed cat, Smilodon gone, horse. So we lose a lot of them. And then this has been a big debate among scientists since like the ACE, I think is the earliest stuff. There's two major ideas and then like a third kind of hybrid. So one is, for those listening, the climate change hypothesis. We're going from fully ice age conditions in North America to interglacial conditions. There's changes in the distribution of plants that maybe affected populations, and maybe climate change rapid enough that it caused the die out or something along these lines. But there's a lot of weaknesses in that theory. One is that a lot of these megafauna survived plenty of previous interglacial glacial transitions, and they seem to survive fine during those other transitions, like the Eemian, the previous interglacial to glacial transition. So there's something missing. So the second major hypothesis is the overkill hypothesis, the human hunting hypothesis, which is humans show up something 16-ish thousand years ago, and they really expand with this Clovis culture that makes this really beautiful spearhead projectile point that might be a technology that can kill these megafauna much more efficiently than before, than any natural cause, let's say. But as we mentioned, certain things don't go extinct. There's a lack of abundant kill sites in North America that you would suggest there'd be these massive mastodon or mammoth piles of bones from these thousands of animals being slaughtered. Maybe they're just not piled, but that's one piece of evidence that's sort of missing. And then we have this bison issue that seems to, certain megafauna seem to make it through. So the third major one is the combined climate human-driven hypothesis, where the rapid climate change, along with the introduction with the new predator humans, with this new technology, stone spearheads, they were enough to push a lot of these large-bodied, slowly reproducing mammals enough to push them towards extinction, or at least extirpation regionally, until maybe pockets were isolated that thrived maybe for a few thousand years, but eventually seems that those also die out or maybe are invaded later on by humans. So Chris, can you speak to the theory, the hypotheses behind the megafauna extinction, it sounds like to you, you found evidence that some of these megafauna are already going extinct before humans. Some things like the Columbian mammoth, you solidly think that's probably human-driven extinction. So can you comment just broadly on the megafauna extinction and what you think is causing it?
Sure. I think one thing that is becoming increasingly clear is that we need to not think of the megafauna extinction as a unique spot in time. Like when we think about the extinction of the dinosaurs, we look at that and go, okay, roughly 65 million years ago. And it looks almost instantaneous. One of the advantages to working in the time frames where you can do radiocarbon dating or working in near time, is we just have much more evidence available to us. And I think one of the things that we're increasingly seeing is that the cause of extinction may not be the same across the board. There may have been different impacts that affected mastodons versus mammoths versus giant ground sloths. And the degree to which animals were impacted, let's say the degree to which an animal might be impacted by that environmental change, may not have affected animals in the same way across the board. And so I think the key to understanding Ice Age extinctions is really starting to look at individual taxa and look at, regionally, what is the timing of those? So you mentioned the mastodon. I think the fact that we see that populations of mastodon are going extinct in some places, going locally extinct in some places well in advance of that 10,000 years and well in advance of the arrival of broadly spread populations of people, suggests that there were environmental factors that were affecting some of those populations. Now, whether that was the thing that totally wiped them out at the end, those are things that we still need to try to parse out. I do think I talked a bit about mammoths and mammoth extinction. We know, there's not a lot of sites, but we have, we continue to find sites that suggest human mammoth interactions. And I was a co-author on a paper that recently came out that looked at diet in a human individual from Montana. And it suggests that some of the first people that were arriving in North America were definitely had mammoth as a component of their diet. So I think, it's studies like that will continue to build our understanding. But I think we need to move away from the idea that there's a single explanation that explains the extinction of Ice Age megafauna, because I think the reality is that for each taxa, there are nuanced and potentially different explanations for why we lose those animals.
Okay. And at the mammoth site itself, you're saying you're finding evidence that humans are certainly eating or hunting these mammoths and mastodons. But at the mammoth site itself, you don't find any evidence, right?
No, because the especially now when our youngest age estimate for the upper part of that excavation is 125,000 years, that would precede the establishment.
Oh, okay.
It would precede the establishment of widespread populations of humans.
Got it. So the mammoth site is the youngest deposits are 100,000 years old.
Yes.
Oh, so we have no late Pleistocene boundary in there. No. Why doesn't it have any Holocene sediment?
Yeah, because the sinkhole was filled. So the sinkhole, over time, the sinkhole filled.
I got it.
As the spring water left, it cemented the deposit together. And actually, all of the land around the sinkhole eroded away faster than the sinkhole did. So the sinkhole actually became a hill. When the site was discovered, the site was actually being bulldozed to put in a housing project back in 1974. And that's how the site was discovered. So yeah, the sinkhole over time turned into a hill because of geologic processes, cementation and erosion. Turned the sinkhole into a hill.
We should have talked about that at the beginning, because that would have... So the geology is not as simple as just a hole, or at least today, it's not just a hole in the ground, but at one point it was clearly a hole that filled in. and preserved all these things. And the youngest bits is about 120,000 years ago. So you don't actually, I guess, capture that boundary between the Holocene and the Pleistocene and that exact extinction. So that what you're seeing in there that's interesting, though, that you're capturing definitely pre-human, like pure megafauna landscape of the Pleistocene.
Yeah. And I think sites like that have potential, if we could ever get ancient DNA out of those. One of the interesting things that could come of that is looking at what did the genetics of those populations look like, and how does that compare with some of the late Pleistocene stuff? Were those late Pleistocene, what do the genetics tell us about late Pleistocene faunas relative to some of those earlier time frames? Was the genetic health of populations of mammoths severely altered as we get into that terminal Pleistocene time? Sites like the Mammoth site have the potential to give us a framework for comparison if we can get ancient DNA out of the bones. And thus far, I'm not convinced that we'll never be able to, but it hasn't proven to be a fruitful search thus far.
Well, how about not the bones, but can't you use the teeth? Aren't the teeth appetite?
I actually just had a meeting this morning, and I'm hoping that we're going to, we're going to test it again. So, yes,
I think the appetite in the teeth, like inside the tooth, is where you're going to. If anything's preserved, the collagen in the bone is gone, but the tooth may have genetic material inside if you get a nice one and preserved.
That's the hope. So stay tuned.
Oh.
I just had a meeting this morning to talk about the potential of doing some of that work. We're gonna do a bunch of genetic work there's gonna be a bunch of genetic work done on some of the material that we have here from Alberta, and I'm gonna put some of that try to see if anything will come out of some of the mammoth site material too.
Okay, that's interesting. When I look at the this megafauna extinction, especially in North America, I am leaning towards, I think, the human overkill hypothesis, and not just from direct evidence in North America, but if you look at elsewhere around the world. Like if you look at places where megafauna, generally speaking, thrived all the way through the Holocene up into the late Holocene, like Africa, they kind of co-evolved with these bipedal hominids that like to throw spears. And similarly through the Fertile Crescent area and other places like that. I know a lot of these were eventually domesticated, like the auroch to turn into cow, obviously the horse, in the old world. But so they seem to survive, they're co-evolved. But when it seems like humans are introduced into the landscape following in the Holocene, when they're introduced, you often see extinctions. Like New Zealand is a really good example. It's weirdly uninhabited until about 1,000 years ago, roughly speaking, by Polynesians. And even though Australia is right nearby and had been inhabited for like 50 to 100,000 years by modern humans. But right when humans show up during this, it's during the medieval climate anomaly, 1,000 years ago. You could maybe argue there's a drought, there's fires rage across the island, but I think that's human induced. But all the big megafauna flightless birds that are easy targets, gone. You also see that in a lot of island environments where the big bodies. So to me, when I look at that, I'm like, okay, humans are the most unique thing that happens in North America in in geologic history. And once they show up, they're gone. But I do think then there's that pressure, like you're saying, like if you move the Southwest United States, Arizona, Utah, huge lakes, extremely wet relative to today. And those things dried up. We know they did by the Holocene. If you're a large-bodied mammoth living there, it doesn't matter if you're a human or not, it's going to push you into a new range. And whether or not that would probably be driven locally, but it will push you to a range where other humans are going because they're looking for the same thing, water, food. And then they're going to be converging on this whole environment. And so I still think, you could say that climate change kind of like maybe made them move their ranges, but overall the extinction maybe is driven by humans. then you have minus those weird island effects with like Channel Island and the island north of Siberia. But even now thinking about that, they survive on that island till what? Human evidence is, at least in the Siberian island, they find human evidence like 3,000 or 5,000 years ago. And that's exactly the same time the pygmy mammoths go extinct on that island. So yeah. Any thoughts on that?
Yeah, no, I think there's really, I mean, I think it was folks out of the University of Wyoming published a paper kind of that looked at sort of the synchronicity of the loss of populations of mammoths with the movement of humans across Europe and Asia and into North America. And I mean, I think anytime you introduce a new predator into a landscape, it's going to have an effect. I mean, we see it today when invasive species are released into new habitats. It has an effect on populations. So yeah, I think especially for mammoths, I definitely think there's strong evidence to support that humans did have an impact on the existence of those populations. Now, whether those populations were already stressed because, as you pointed out, because of environmental changes that are going on, that's where I think it's that sort of nuanced approach, right? Because those populations may have been extremely stressed by some of the environmental changes that are going on. And then you add that new predator, that may have been the thing that contributed to the final loss of a lot of those populations.
Now, when would you say the last mammoth, what's the youngest mammoth date in North America?
Excluding the Wrangell Island stuff?
Yeah, excluding those anomalies.
Boy, I would have to look. I think some of the stuff we have from Alberta would be pretty close. I mean, we have some stuff that is around, I think, I need to double check, but 10,200. So right around 10,000 years ago.
So is that calibrated, or is that just a raw radiocarbon?
Raw radiocarbon.
Okay, yeah, 10,000 C14 years. And if the top of my head, so doesn't that calibrate to like something like 12-ish or 11, something like that?
Yeah, I definitely do that calculation in my head.
Yeah, we definitely cannot do that, but let's not put that on record. But if I look it up, I'll try to do a zoom in. So, but okay, let's just say about 10,000 radiocarbon years ago. We'll just leave it at that. And how about the horse goes extinct? And so I have a date here of 10,870 plus or minus 45 BP for the North American horse in Alberta. That's at the Pashley gravel pit.
Yep.
You know that site?
Yep.
And then we have, so the bison makes it through, because I tried to write down a list. How about the saber-toothed cat?
Ooh, that's a good one. I would think that some of the stuff from La Brea would probably be some of the latest records, but I don't quote me on that. I don't know off the top of my head.
La Brea. Now, there's a raging debate online then, and this is what I'm trying to get at, is this younger Dryas happened.
Right.
Now, I'm trying to think of how to say this because I don't want to lead you to think my way, but from what we can tell, are these extinctions happening during the younger Dryas? Like, does it seem to be converging there? Or does it seem to be that they're becoming extinct prior to the younger Dryas?
Well, again, I think it depends on where you look regionally.
Yeah, okay.
I mean, I think that's one of the projects that I'm currently working on for some of the work up here in Alberta is compiling all of the radiocarbon data that we have, which is somewhere between 500 and 600 radiocarbon dates on megafauna. Part of what we're trying to do is look at that very thing. Say, okay, when do we lose certain things? When do we lose them before the ice advances? And then when do they go extirpated prior to the LGM? Mm-hmm. And then when do they become extinct? A lot of the a lot of the things that we see are we're losing around that 10,800 year time frame. The site, there's a site we're working in southern Alberta called Wally's Beach, and it's got a really, really tight window of megafauna. The megafauna so caribou, horse, camel, it all dates from roughly 11 to 11.8 radiocarbon. And then we don't see much after that. There may be a couple of those gravel pit records, although I would caution, I would need to go back and look at those and double check on when those dates were done, because those may be things that we may need to retest some of those radiocarbon dates. Because like anything else, as new techniques develop, the refinement of radiocarbon has just continued to improve and improve and improve. And we do see some subtle variations. Sometimes when we go back and we date things that were dated 40 years ago, we get a different age. So, and that's especially that for a lot of the work that I do, that refinement doesn't make that much difference. But when you're asking questions about extinction and extirpation, it's hugely important. And the timing, it's hugely important. So I think, we've got good evidence of some of the last gasp of Ice Age megafauna here in Alberta from about 10,800 years ago to 11.4, 11.5. And that seems to be the window when we're losing a lot of things. So now I'm assuming you're going down the road about the impact hypothesis.
Well, we could go there. We did talk about that. I talked about it on this channel with Vance Holiday. And
okay,
yeah, he's not in the Younger Dryas impact hypothesis camp, or not in favor.
I would say that I think I see too many other things affecting. I'm not saying that couldn't have had an effect, but I think to argue that is the one thing that led to the extinction of the Ice Age megafauna is ignoring a whole body of evidence that suggests that no, we're losing things regionally at different times.
Yeah.
So,
and there's a bunch of other issues with it, and if you haven't seen it, if you're interested in the Younger Dryas impact hypothesis, the guy that wrote the paper that went through all the evidence, Vance Holiday, I talked to him on this channel. You can check it out, but there's some issues with that hypothesis. So I wonder if it'll stand the test of time. The thing that I think is weird, the reason I think the Younger Dryas is weird for the megafauna is that for me, I'm a paleoclimatologist. I'm a geologist at working University of Hawaii. So I know that there's big climate changes after 18,000, between 18 and 13. I mean, there's enormous changes. The only difference between the Younger Dryas is merely a slight reversal in cooling, right? And even though this reversal, we call it, happened maybe over a decade, pretty rapidly, which is not debated. But what caused it, I guess, is debated. But it's probably a shutdown in the North Atlantic circulation. Why did that one cause the extinction? Why didn't the extinction, I guess maybe they were on their way out. It took them like thousands of years. But why did that little reversal that they all seem to converge at like that 12 to 13,000 calendar year period during this rapid reversal in cooling? They were in a cold environment. Do you see what I'm saying?
Yeah, I get you.
So like that didn't point straight towards humans because like that's definitely the most unique factor in there. But otherwise, where I then wanted to finish with this was that La Brea tar pit, though, they do show that the megafauna are going extinct prior to the Younger Dryas. And I don't know how the dating is in that, but they're finding that the big megafauna become more and more, increasingly more rare as you approach about 13,000 calendar years. And so that is like, in that Southern California, that's a tar pit. It's a slightly different. But that to me then is like, oh, okay, then that's for sure showing that the environment is driving this, not necessarily this kind of event. And the weird thing with the Younger Dryas event is also it overlaps so closely with the dates for Clovis. I mean, a slight cooling reversal, or this people that show up with a spearhead this big, and and they're probably very good at throwing that. It seems like that's another strange bit of evidence. But then the Brea tar pit again counters that again. So maybe their dates are off there, and they're just saying that these megafauna are on their way out before the Younger Dryas.
I suspect the dating. I suspect the dating there is pretty good.
You think?
I think again, it comes for me. It comes back to the point that, you know, I know we want the explanation. We want, you know, it's this or it's this, the black or the white. And the reality is, science is, you know, what we do is messy. And it's messy and it's nuanced. And honestly, that's what I think, you know, I think I could speak for a lot of us, right? That's part of what makes this fun, is trying to understand that complexity that leads to those patterns. Because ultimately, I think one of the things that's great about what we do when we work in the Quaternary is we're essentially working. I mean, we're working with the modern. I always tell people, like, for what I do, we think of mammoths and some of these other animals as, oh, they're ancient. You know, they're not dinosaurs, but they're ancient like that. And in reality, we're studying the modern biota. We just lost some big stuff along the way, and you know, understanding those patterns and understanding the nuance is actually the thing that I think over the long term is going to give us predictive power about where we're going, where the planet is going. So,
interesting.
I like the messiness. I like to wallow in the messiness, I guess.
Would you be in favor of a Jurassic Park style reintroduction of megafauna to the Arctic through genetic work? Would you support that?
I just had a conversation with some ancient DNA folks this morning about this. I think that potential technologies that could come out of that could be really, really interesting. I don't like the idea of bringing something back just to turn it into a zoo. I mean, I think we've got lots of conservation efforts that we should be focused on. And frankly, I think you're bringing something back into an environment that is not the environment that it lived in, right? When extinction is part of the extinction of those animals is part of a natural process. And I think arguing that I do think humans probably had an impact, but I think arguing that, well, because humans had an impact, that means we should bring them back. It sort of decouples us from nature. And sets us up to say, oh, well, we're something different than the rest. And yeah, in some form or fashion we are, but that decouples us in a way I'm not comfortable with. So I am not, like, if you sit here and ask me, am I going to go look at a mammoth if they clone one? Yeah, I'm going to go look at a mammoth.
Me too. I'll be the first in line.
But do I think we should be bringing them? I mean, I think bringing them back just to
stare at them
is not a reason to do it. So, but I think the technological side of it, I mean, I think there's probably some good arguments to say, you know, the technologies that could come out of an endeavor like that may be worthwhile in ways that we can't even imagine.
Or saving potentially current species going extinct in some ways that technology might be useful for.
Absolutely.
But just, you're Canadian? Do you live in Canada? I mean, I know you live in Canada, but...
I'm a dual citizen.
Okay, dual citizen. You should go lobby and say, you know, we want to have an island. One of those islands in the North Arctic, Canada, that's where they're going to repopulate the Ice Age mammals, on one island. And then we can go there and just imagine the tourism, just imagine all the coffee you'll sell and all the T-shirts. And Canada would, you know, you have an island full of woolly mammoths and other Ice Age critters just running around out there. And we can pretend like we're, I don't know, back in the Ice Age. But yeah, it would be, the genetics part brings in the ethics, which as a geologist, I just like chemistry and paleoclimate. And I never really consider ethics too much.
Yeah.
I would be the first person, I'm not ashamed to say, to go and check it out if it ever happened one day, or maybe brought back some reasonable megafauna. I know in like the Mongolia, there's this effort to repopulate the native horse
Yeah.
from
I'm
zoo populations in Europe.
actually less bothered by that. And I'm less
Yeah.
bothered by things like trying to bring the dodo back.
Oh, the
Because
dodo. I didn't know about that one.
yeah, because there is, or some of the Australian marsupials, what is it? The thylacine is
Mhm.
another one that I think they're
Yeah,
working on.
the fox thingy. It's like a fox looking or
Yeah,
wolf. The side.
carnivorous marsupial. Yeah, yeah.
Whoa.
So I think I don't know, for whatever reason I'm less, and I guess I'd have to do some more soul searching. I'm less bothered by those than I am mammoths. And part of it, I guess, is because I think the extinction of the mammoths is more nuanced than just being a direct result of people. I think
Yeah.
there were other factors at play. And I think at some level, extinction is part of the evolutionary process.
When did mammoths go extinct from Siberia?
From
Around the
excluding
same
Dingle
time?
Island,
Yeah, excluding Wrangell.
I would have to. I would think I would have to go back and double check on the specifics of that, but I think it would be roughly the same time they go extinct in North America.
Yeah, see,
So,
then that one doesn't make sense because there's hominids and humans living in Siberia for the Pleistocene, and they're living, you would think, co-evolving or whatever you want to say with these things.
but that's actually that's a perfect example of what I'm talking about. Is that you can have different reasons that are the driving force behind those extinction in different places.
Mm-hmm.
And I think when we talk about the extinction in North America, the arrival of humans is a unique factor that has already played out in other places.
Yeah.
Right?
Yeah. I see what you're saying. Yeah. And then like the range of the elephant, it's been severely restricted in the modern period. Like 1,000 years ago, maybe I can look up a map to put on here. Like, how far did the modern elephant range? I know the species, there's the Asian, but broadly speaking, the range is still pretty big by the late Holocene.
Yeah, I don't know. I don't know in terms of modern elephants. I don't know.
Yeah, you
I
don't
just
know.
don't know enough about those range shifts to comment on that.
Okay.
So,
Because then it seems that, the mammoths go extinct, the mastodons go extinct, but then somehow these smaller elephants that live in tropical areas or smaller proboscideans, they survive then. Maybe they become, just like the other megafauna, like the auroch, the horse, they partly become domesticated, and that kind of carries them through.
well, or I mean, if you think about it, a lot of human evolution is probably happening in those places in conjunction with the evolution of those proboscideans too, right? So, I don't know, maybe there's different behavioral factors that come into play, and I don't know.
Yeah.
I don't know. That's interesting to think about, though.
And the elephant's never been domesticated from a technical sense. Like the zebra has never been domesticated, but the elephant, right, is just always considered wild.
Well, I don't know. I thought the Romans used
Yeah, I know. They go back
elephants?
in like ancient Indian armies, like in India,
Yeah.
used them like thousands of years ago. That's what makes me think that they were going extinct, and they're like, okay, we can use these things just like we domesticated horses, camels, the auroch, the cow. And then they, empires rise and fall, and they escape, their herds escape, and they think they're wild. And then they become, I don't know. Like, this is all coming to me right now as I'm talking to you. And I've never thought about them at all. And so maybe this is a good time to wrap up our conversation before we get too far down another rabbit hole.
All right.
I think I covered everything I wanted to talk to you about. And I wanted to just remind the listener that you're the paleontologist for the Mammoth site in South Dakota. It's a unique site with tons of mammoth fossils in an old sinkhole deposit, which they'd fallen into 100,000 years ago and before that. And you're also currently at the Royal Alberta Museum, and you have your PhD. You've been studying this stuff for your whole career. And by the way, Jim Mead sent me your contact, your advisor.
Okay. Yeah.
Because I had talked to Vance Holiday, and I was like, after I talked to him, I'm like, I just need to know about these Megafauna extinction. I feel like this is like, everyone wants to talk about Clovis, prior to Clovis, as a geologist, all I've thought about is the pure climate aspect of it. But I was like, where are the paleontologists studying this stuff? And he was like, you have to talk to Chris Jass.
Awesome.
Do you have any shout outs you want to make or any final comments?
Just, everything I've talked about today, projects that we're working on, I think it's always important to just emphasize that these things are not done in isolation. There's a whole slew of collaborators that that as scientists that we work with. There's people that, we work with here at the museum and at the Mammoth site that all contribute to this. And so this is by no means, it's certainly not the research that I do, and the work that I do is not a solo endeavor. There's a lot of people that feed into that. And so I always like to tip the hat to all of those people who have allowed me to spend the better part of my career just working on things that I'm curious about. So
it's almost like your hobby is your career, is your life. Is that what you say?
It is. It is. Yeah. I'm never going to drive a Tesla, but I've got to spend the better part of my life working on things that interest me. That's kind of hard to beat.
That's amazing. Thank you, Chris Jass, for tuning in. And thank you to everyone that watched our interview. I hope you go check out Mammoth Site in South Dakota. Until next time, Chris, till I see you at a meeting or something, or you have another paper, just send me an email and you can come back on the show and talk about any of your new findings.
All right. Sounds good. Thanks, David.
Yep. Thank you. Bye.